For centuries, physics has relied on a small number of experiments that shaped how humanity understands reality. These discoveries weren't just scientific milestones, they became foundations. They defined what we teach in schools, how we build technology, and even how we think about the universe itself. But what happens when scientists begin to question one of those foundations? One of the most important experiments in the history of science is the double-slit experiment. First performed over 200 years ago, it revealed something completely unexpected. When light was fired through two tiny slits, it didn't behave like a stream of particles. Instead, it formed a wave-like interference pattern, as if each particle somehow traveled through both slits at the same time. Later, the experiment was repeated with electrons and even larger particles, and the strange result remained the same. This led to a shocking conclusion. At the most fundamental level, reality doesn't behave logically. Particles act like waves, outcomes are probabilistic, and observation itself seems to influence what happens. This experiment helped launch quantum mechanics, one of the most successful theories ever created. It powers modern electronics, lasers, GPS, and computers. But alongside its success came a deeply unsettling idea that reality itself may be unknowable, uncertain, and fundamentally strange. Now, new research is forcing scientists to pause and rethink that story. Physicists are revisiting the double-slit experiment using modern theoretical tools and simulations. What they're finding is that the famous interference pattern may not require particles to behave like mystical waves after all. Instead, the pattern could emerge from subtle interactions between particles and the electromagnetic fields around them, effects that were previously ignored or assumed to be irrelevant. If this interpretation is correct, it doesn't mean quantum mechanics is wrong. The equations still work. The predictions still match reality with incredible accuracy. But the interpretation, the meaning we assign to those results, may have been incomplete. For decades, physics textbooks taught that particles exist in multiple states at once until observed. But this new perspective suggests something less mystical and more physical, that complex interactions, not paradoxes, may explain the behavior we see. This has enormous implications. It challenges centuries of philosophical assumptions about reality, observation, and certainty. It suggests that the universe may not be as bizarre as we once believed, just far more subtle and complex than early experiments could reveal. Most importantly, this moment reminds us how science truly works. No idea is beyond question. No experiment is beyond re-examination. Even the most celebrated discoveries are not final truths, but stepping stones. Physics isn't being torn apart, it's being refined. And if one of the most important scientific findings in history turns out to be misunderstood, that doesn't mean science has failed. It means science is doing exactly what it was designed to do, moving closer to the truth.